Ladies and gentlemen, I want to start with a simple confession. I don't really know how the universe works, and not completely. It might sound disappointing, but actually, it's the most exciting part because the universe isn't an ID machine with a user manual. It's more like a grand puzzle, full of strange rules, surprising patterns, and mysteries that don't quite behave the way our everyday intuition expects them to. The same laws that make an apple fall to the ground also guide the motion of planets. Weirdly, the same tiny particles that make up you and me can behave like waves, like ghosts, or sometimes like something we don't even have a good word for yet. Pretending we have all the answers. What I'd like to do today is something much more fun. Explore the question itself. What does it really mean to say we understand the universe? How do we actually come? And perhaps most importantly, how much stranger is reality than we're willing to admit? Because when you look closely enough, the universe doesn't just work, it surprises you. That's where the real story begins. Ladies and gentlemen, I want to begin with a small confession, something that might sound a little strange at first. I don't really know how the universe works, and if we're being honest, nobody does. Not completely, anyway. Now, that might seem like an odd way to start a talk that promises to explain how the universe actually works, but in a way, that's exactly the point. The debate about the universe is not that we have all the answers, it's that we don't. When people hear the word science, they often imagine a collection of neat facts, finished ideas, and solid conclusions. That's something complete, like a book that's already been written. But that's not what science really is. That is more like a process of constant discovery, a kind of exploration where every answer leads to new questions. It's a way of looking at the world and saying, that's interesting. I wonder why it works that way. Take something as ordinary as an apple falling from a tree. It seems simple enough, right? Things fall down. We're used to it. But if you stop and think about it, it's actually quite mysterious. Why should objects attract each other at all? Why does the earth pull on the apple pull on the earth? I'm even more curious. Why does that same invisible force reach all the way up to the moon and keep it circling around us? Remarkable is that the same set of rules, the same underlying principles, can describe both the falling apple and the motion of planets. That's one of the beautiful things about the universe. It operates with a kind of consistency that allows us to begin understanding it. But just when we think we've got it figured out, things start to get weird. If you look closer, much closer, down to the level of atoms and the tiny particles that make them up, the universe behaves in ways that don't match our everyday experience at all. Particles don't just sit in one place like little marbles. They spread out like waves. They can be in multiple places at once. At least that's the best way we can describe it. And carefully, they seem to change their behavior as if the very act of looking somehow matters. Now, that's a strange idea. It's not the kind of thing you can easily picture, because it tells us something about the limits of our intuition. The human brain evolved to deal with everyday objects, things we can see, touch, and throw around. Are designed to naturally understand the behavior of tiny particles or the vast structure of the cosmos. So, when we say we understand, we don't necessarily mean we can imagine it perfectly. What we mean is that we found patterns, rules, and mathematical descriptions that reliably predict what will happen. Patterns are incredibly powerful. They allow us to build technology, send spacecraft beyond our planet, and even glimpse the earliest moments after the universe began. But they also come with a kind of humility, because every time we discover something new, we uncover deeper layers of mystery underneath. So instead of thinking of the universe as something fully explained, it's better to think of it as something we are gradually learning how to ask better questions about. And for a moment, the idea that we can understand anything about the universe at all is already a little surprising. After all, we are tiny creatures living on a small planet, orbiting an ordinary star in just one of billions of galaxies. Now, we've managed to figure out patterns that apply not just here, but everywhere, across distances so vast that light itself takes millions or even billions of years to travel. We've done this is by noticing that nature seems to follow rules that don't change from place to place. The same physics that works in a laboratory here on Earth appears to work in distant stars. Yet, when we look at the light coming from those stars, we can tell what they're made of, how fast they're moving, even how hot they are, all without ever going there. Not because we visited them, but because the universe behaves consistently enough for us to decode its signals. But there's an interesting twist here. Might these rules we talk about aren't things we can see directly. You can't pick up gravity and hold it in your hand. Point to a law of physics and say, there it is. What we actually observe are events, things. And from those, we build models, descriptions, and equations that seem to capture the patterns. In other words, what we call understanding is really a kind of approximation, a story we tell that matches what we see. And sometimes that story changes.
One point.
People thought space and time were fixed and absolute, like a rigid stage on which everything else happened. But then along came Albert Einstein, who showed that space and time are flexible, that they stretch and bend depending on motion and gravity. The universe wasn't just a backdrop anymore, it was part of the action. That shift didn't mean the old ideas were completely wrong. In many everyday situations, they still work just fine. But it revealed that our understanding was incomplete, that there were deeper layers waiting to be uncovered. You see again and again in science. Each new discovery doesn't just add knowledge, it reshapes how we think about everything that came before. There's the question of scale. On very large scales, the universe looks smooth and ordered. The galaxies form patterns, clusters, and vast structures that stretch across space. But zoom in far enough, and that sense of order begins to dissolve into uncertainty. At smallest scales, the universe becomes fuzzy, unpredictable, almost as if reality itself refuses to be pinned down precisely. That is a fascinating question. Is the universe truly deterministic, like a clockwork machine where everything follows exact rules? The mental randomness built into the fabric of reality. Randomness isn't just a result of our ignorance, It may be an essential feature of how the universe works, and that can feel unsettling. The idea that things happen for clear, predictable reasons, but the universe doesn't always cooperate with that preference. It offers probability, ranges of outcomes, and behaviors that only make sense when you look at them statistically. Remarkable, though, is that even with this uncertainty, we can still make incredibly accurate predictions. How particles will behave on average, how stars will evolve, how the universe itself has changed over time, Nature allows a kind of partial understanding, enough to reveal its structure, but not enough to remove all mystery. So when we talk about explaining how the universe actually works, what we're really doing is building a bridge between what we can observe and what we can imagine. But knowing all the while that the bridge is still under construction. And then there's perhaps the most curious part of all, the fact that the universe is not just something out there for us to observe. And we are a part of. Every atom in your body was formed in the heart of a star. Every bones, your blood, even the air you breathe, were created through processes that began long before the Earth even existed. In a very real sense, when we try to understand the universe is trying to understand itself. Now, that sounds poetic, but it's also grounded in physics. The mass that govern distant galaxies also govern the neurons firing in your brain. There is not one set of rules for the cosmos, another separate set for you. Connected. And that raises an interesting point. Our ability to think, to question, to be curious. These are not separate from the universe's behavior.
These are not separate from the universe's behavior.
But here a consequence of it. But here's where things get tricky. When we observe something, we usually imagine that we are just passive spectators standing outside the system we're studying. In everyday life, that works well enough. You can watch a ball roll across the floor without affecting it very much, but at very small scales that idea breaks down. The act of observing can actually influence what happens. This isn't because there's something mystical going on, but because observation requires interaction. That or some kind of signal to bounce off it at the scale of tiny particles. Even that small interaction can change the outcome. The relation between observed and being observed begins to blur. Physicists struggled with this idea for a long time, and in many ways they still do. Forces us to rethink what we mean by reality itself. Is a particle in a definite place before we measure it, or does the act of measurement help define its position? The interpretations exist, and each one has its own way of trying to make sense of the same mathematical framework. And that brings us to another important point, mathematics. For reasons that are still somewhat mysterious, mathematics turns out to be an incredibly effective language for describing the universe. It's written on a piece of paper can predict the behavior of objects we have never seen. In places we've never been, it's almost unreasonable how well it works. We should be careful not to confuse the map with the territory. The equations are not the universe itself. They're tools we use to describe it. That organize our observations and make predictions, but they don't necessarily tell us what things really are at the deepest level. Sometimes we have equations that work perfectly even though we don't fully understand what they mean in an intuitive sense. So where does that leave us? It leaves us in a position that is both humbling and exciting. We have discovered an incredible amount about how the universe behaves. That's its history back billions of years. Understand the life cycles of stars and probe the truth. That matter at astonishingly small scales. And yet, there are still profound questions that remain unanswered. What is the universe made of at its most fundamental level? Why do the laws of physics have the particular form that they do? The deeper principle underlying everything? Or is what we see simply the way things happen to be? These aren't just technical questions for scientists. They touch on something much broader, the human desire to make sense of the world, to find patterns, to seek explanations. Perhaps the most important thing to realize is that this process doesn't have a final endpoint. It's not about reaching a moment where we can say, that's it, we figured everything out. It's an ongoing journey, one where each new insight opens the door to even deeper mysteries. The act of questioning is just as important as the answers we find. There's another aspect of the universe that's easy to overlook, simply because we're so used to it. The fact that it is understandable at all. Not perfectly, not completely, but to a remarkable degree. The patterns we discover are not random scribbles. They have structure, elegance, and often a kind of simplicity hidden beneath complexity. But the mole is something worth pausing over. Think about how a few basic principles can explain such a wide range of phenomena. The idea of energy conservation applies whether you're talking about a bouncing ball, a flowing river, or the fusion reactions inside a star. It doesn't matter where you go. The rule seems to hold. And not just approximate, but with astonishing precision. It's as if the universe is built on a set of underlying instructions that remain consistent no matter how or where you look. That doesn't mean those instructions are easy to read. In fact, most of the time, they're written in a kind of language that feels very far removed from everyday experience. This is where scientists rely heavily on abstraction, on symbols, equations, and models that capture relationships without needing a direct visual pitch. While that can make things harder to imagine, it also allows us to go far beyond the limits of our senses. Take time, for example. We experience it as something that flows steadily from past to present to future. But when physicists study it closely, they find that time doesn't behave quite so simply. Depending on how fast you're moving or how strong gravity is, time can stretch or slow down. What feels like a constant to us turns out to be flexible, shaped by the very conditions of the universe. Or consider empty space. It sounds like nothing, right? Just a void with nothing in it. But modern physics tells a very different story. Even in what we call empty space, there are fields, fluctuations, and activity happening at incredibly small scales. Particles can appear and disappear. Energy can shift, and the vacuum itself has properties that influence how the universe evolves. What we once thought of as nothing turns out to be something quite complicated. And then there's the question of scale again, but from a slightly different angle. Laws of physics don't just apply across space, they apply across time. When we look out into the night sky, we're not just seeing distant objects, we're seeing the past. Our galaxies has taken millions or billions of years to reach us, which means we're observing those galaxies as they were long ago. In a sense, telescopes are not just instruments for looking far away, but for looking back in time. This gives us a kind of cosmic history book, one that lets us piece together how the universe has changed. We can see how galaxies form, how stars are born and die, how structures evolve over immense stretches of time. A type of a universe that is dynamic, not static. A universe that has a history, a present, and a future. A present and a future. But always knowledge. There's always a gap between what we can describe and what we can fully grasp. Down equations that predict how space expands, how matter interacts, how energy flows. We can test those predictions with experiments and observations. And observations with his experiments and observations with experiments and again. Yet there remains a sense that we are only scratching the surface, that there are deeper connections waiting to be discovered. Perhaps that's exactly how it should be. If the universe was simple enough to be completely understood in a short time, it might not be nearly as interesting. The challenge, the mystery, the constant need to question and rethink, that's what drives discovery forward. And we try to explain how the universe actually works. We're not just listing facts or presenting final answers. We're engaging in a process of exploration, one that combines curiosity, imagination, and careful observation. Always aware that whatever picture we have today is likely to be refined, expanded, or even completely transformed as we learn more.